Welcome back to the second part of this Insights sample case. In the first part we designed primary telescopic crowns. In a normal workflow, these telescopic crowns will be milled and then they will be scanned again, obviously with a tactile scanner, and then you create the secondary crown and the removable partial framework on this second scan. To do that, so we are still here in the project of our first case, you simply duplicate the case and you even duplicate the scan data, and now you can change the project and you will change the telescopic crowns into copings, and then we will add some reduced pontics, the same material here. We will connect all these parts and then you can define here the partial framework teeth, and then you click on save, and now you would scan again the model with the telescopic crowns, and then you continue the job here. So I have not the ability to scan it now, therefore I already prepared the case with the scan of the telescopic crowns we have just designed. Here it is. And then we go simply to the design. As we duplicated the case with the scan files, the project will be now opened again with the initial scan, and the first thing we have to do is now to import our second scan with the primary telescopic crowns. Therefore we go to the expert mode, to tools, add remove mesh, then we select extra draw scan, click on load, and then we import our new jaw scan with the telescopic crowns, and then we click OK. Yeah, now everything looks a little bit messed up. This is because again we have to register the pre-op scan. We could also have exported it in the first design session after having registered it, but I did not do that, and therefore we just registered again. And our new scan with the primary telescopes is also at a different position than the initial scan. But don't worry about this, we will be guided through the wizard to arrange all the scans again. There's just one important thing to know is you need to know which one is at the correct position, and this is the initial scan. So let's proceed with the wizard, and we start with the registration of our pre-op scan. It's the same as in the first part. I click on automatically and I choose some teeth as a reference and some significant areas on the papillas. We perform the alignment, the best fit matching. Okay. Yeah, in the second step now we can register and match our new scan on the initial scan. And here we usually have exactly the same model, just only in the first model we have the dies, and in the second model we have the telescopes on the dies. And as the model is exactly the same, the registration is quite easy. So make sure that you look at it from the same direction, and then you place a point in the same area on both scans, and automatically those will be registered and matched. And the software will now also delete the old parts. This is what we are asked now, and we have to click OK, and all these parts, for example this overlapping areas here, will be deleted from the initial scan, and we will work on the second scan. And here's the result. Yeah, now we are working with our second scan. You can see that maybe even the dies are still here inside of the scan, but that's not a problem. And our pre-op and antagonist, everything is now at the right position. Yeah, that's great. Now we can start with the design. And first of all, we start the virtual articulator. And here in the Valletta version, we have a new feature in the choose which teeth influence articulator movement. And this new feature, with this new feature, you can now even brush areas on your scans, or you can even mark entire teeth to be excluded from the articulator movement simulation. This will be usually done when you know that the tooth will be extracted, for example. You will find more about this in a separate tutorial on our YouTube channel. Let's cancel this one and let's just start the movement simulation. The movements will be performed and the result of this will be saved, let's say, into the cache of the software. Now we can close the virtual articulator dialog by clicking OK, and we only need to do this operation once, and in the same time we get a new window here where we can still perform all the movements of the articulator. Yeah, now let's proceed to the next step. The next step, we will define the margin lines on our telescopic crowns. Then we choose the insertion direction parallel to the insertion of the telescopic crowns, whereas this is honestly not very important here because later we will uncheck the option to block out undercuts. Yeah, cement gap step. Yeah, this will be used a little bit different when working with secondary crowns on telescopes. And here usually I choose not to have a green and a yellow area, which means that we have a green area without gap or a gap on the yellow area. There are two possibilities to do that. Either you choose distance from margin to 0, then you only have this yellow gap on the entire crown bottom, and then you can choose your cement gap. Let's say it's not really a cement gap because those will not be cemented. So your friction parameter here, and then you could adjust to have here 0.02 on the entire friction area. If you need another value, for example, if you need really 0, then I recommend to choose another possibility. Choose the maximum here from the margin, and then with this brush, you brush the entire cement gaps in green, and this means that you don't have any cement gap at all here. Let's just check the cut view. With the cut view, we can even align it to the insertion direction. Now we see that we still have a very small gap here of 0.02. This is obviously because we have any additional spacing. We have axial and radial set to 0.02, and now we have all the possibilities. We could even define a negative value depending on our manufacturing process of the secondary crowns. Let's choose here 0, and you see, which means that on the entire crown bottom on our primary parts we don't have any cement gap anymore. And furthermore, it's also important in the undercut settings to verify that you don't block out the undercuts. So imagine you have not set the insertion direction now correctly on your primary telescope, then you would create kind of undercuts and they would be blocked out, and that could create a problem for the friction. So make sure that you don't block out undercuts, and make sure that you set the correct value for your tool compensation, which will be used to mill the secondary parts on your primary parts. Then you apply, and then we proceed to the next step. Copy tools feature can be skipped. Now in the tools placement, we do first of all a functional placement. Later on in the smile design, we will do some fine tweaking on the placement and make sure we have a nice aesthetical tools placement. To do our functional tools placement, I usually use the chain mode for such big restorations. And let's have a look how I usually do this. So let's switch to chain mode. Then I grab one of these UFOs, which stands for the distal contact point. Then I fix this position. Then I go to the other end of my tooth bow and fix this one as well. Then I take the canines. And in the same time you can even think about scaling the entire tooth bow in one direction if required. Then I fix this canine and then the other canine, and now you will see or feel that if you are moving this canine, it's quite hard. If, for example, if you fix this one already, then it's much more easy to place this. This is because once you have switched to the red behavior, this tooth will not be scaled anymore, and it's much more easy to place it correctly. Okay, then I do some general placement on the interiors. We can check here with our antagonist. You see here the colors. You can even show the dynamic adaptation, which includes all the movement. And then you would see that you have maybe to change the placement here in this area, and let's switch here and even here. Okay, then let's do the posteriors, and then the posteriors on the other side. And that's all what I usually do with the chain mode. Then I switch back to the simple mode, and if really needed, I do then a final tooth placement in the simple mode. Those teeth are not so important now. They will just serve as a visualizer later when designing the partial software, but anyways, I will try to do the best I can here. because this will help me then to place the finish line. Yeah, and last but not least, I will also check the entire placement with my antagonist. Okay. Let's check again with the jaw scan. Okay, that looks quite good. Yeah, and now I go to the expert mode and I will use the smile design feature to do some fine tweaking or to do some aesthetical placement, especially on the interiors. I go into the expert mode and then into tools and I start the smile design. Yeah, here we start by loading a retracted image, and in the first stage we have to register the retracted image with our 3D scan. In case we would not have any pre-op now of the upper jaw, we could also do the registration with the antagonist with the lower jaw, but in this case we have a pre-op and it's a little bit easier to register those. Yeah. Then usually I take the canine cusps. The bigger the distance between the 2 points, the more accurate is your matching result, because the more accurate is the scaling of the picture in reference to the 3D model. Yeah, this is the first alignment, and then we do a second one, so just adjust the scaling, and with the right mouse we can now rotate the model behind the picture, and you see here, especially in this region, if you are correct, and even here we can now still do some fine tweaking on our scaling. Yeah, and I would say like this, it looks perfect. Then we load the smile image, and this is much easier now. We just have to register 2D with 2D. Again, the bigger the distance, the more accurate is the first proposal, but here this is not a big deal because it's very easy now to match both pictures. Okay. Then we draw the lip line. Okay. Then we click on the patient's eyes to orient or to align the picture correctly. In the project notes you can find the best proportion guide is the 1.25. We place our proportion guide and we adjust the size of it. And then we can adjust the smile curve. I usually adjust the curve here on the bow that's created by the teeth, and I verify it again with the smile image. Yeah. And of course you can also add other helper curves, you can change the proportion guide and so on. Then let's proceed to the next step. Here you can still toggle between different libraries and choose the best libraries. for the aesthetic of your patient, but as we already did a functional tooth placement, I don't want to use this now. And now we can, for example, here in those windows, just choose the anteriors and move the entire anteriors block, or just choose single teeth and maybe follow, for example, here our proportion guide. Like this, and in real time we can see all our actions from 3 different view angles here on the right side in 3D. Of course, we can also check the measurements, so the size of each tooth, and we can also freeform. And then here with the preview button we can have a preview of our result, and we can even change the position of the teeth here in our preview. And could also do some final adjustments here in 3D just to avoid to have such bigger gaps. Like this. Okay. To improve the preview, we can also go to the next step, and here we can use a color picker to improve the rendering of the teeth. I usually, for the base colors, I usually choose a color here which you can find in between 2 teeth, like this orange here, yeah. And as a base color, I choose a highlight color from directly on my teeth, maybe like this. That's not so bad. And you can even go back and still work on the preview now with the improved rendering of your teeth. I think the result doesn't look so bad here. Maybe we can even shorten those premolars. Okay. Then in the last step of the smile design you can save this image to a file or copy it to clipboard, and then you can send this image to the patient or to the dentist. Yeah, by clicking on done we will close the smile design, and we can see again the result of our tooth placement. Just note that if you rotate it, yeah, of course, as it's just 2D pictures, you will change the view, and to get back to the initial aligned view, just double click on the picture here. Yeah, then we can proceed in the wizard, and we continue with the design of our anterior bridge on the telescopic crowns. Yeah, in the True Smile context menu we can now still choose the rendering of the truth of the smile design, like this. And yeah, to continue I will switch off the 2D pictures, and if we want we can now even continue by using this rendering. Yeah, now we can do some freeforming here, and yeah, don't invest too much time here on the posteriors. The most important are the anteriors. Let's switch on again the contact points, and let's finalize the design for our anterior bridge. For the pontics, I usually place them really here with the basal contact parts where they should intrude the gingiva, yeah, like this. And maybe you can shorten it a little bit here, as we have some adaptation there. And yeah, maybe with some freeform we can add some material here. That looks a little bit better, yes. Okay, very important now is to adapt, especially the pontics. In Valletta we have a new feature which is called Cut All Intersections, and for the approximal contact points we have now the disc cutters available. Those will be explained in a separate tutorial, as well as the block out neighbor collisions. And we have here this button, Cut All Intersection, and that's what I will do now. And with one click, the occlusion, the pontics, and the approximal contacts will be adapted. Yes, great. Then we can proceed. Yeah, we can skip this step as our design has been finished, and we just used the pre-op for an initial setup. We don't want to copy the old morphology of the patient. Yeah, and now we can shrink, and this is now a special operation for this bridge on the telescopic crowns. Usually it's a veneered bridge veneered with acrylic, and therefore we just reduce the buccal part, and here I usually choose exclude selected parts, and I choose mark all. I hide the other ones, and then with the brush I just brush the buccal part to be reduced. Okay, the last one. And then you increase the value here at a maximum or 2.5 millimeter at least, and then we shrink just the buccal part. Okay. That looks great. Now we can still do some freeform here. For example, we can adjust here some contact areas or like this, but I would say the design is quite okay. Yeah. Now the connectors, we have two possibilities. We can choose this tooth shape directly feature. This will just connect the restoration on the smallest intersecting area, but with a risk, and you get a warning, that some of them might be very small. Or you could, what I recommend is choose this one, and 6 millimeter should be enough, because as everything will be connected as well by the partial later, and then you can move it, place it, and you are sure to have at least 6 square millimeter everywhere. and then we proceed. And then we can still freeform the entire restoration. And here we can, especially for example, just smooth these areas here. And you can even create a little bit more space here. Much easier to separate the teeth later in the acrylic here in this region. Okay, yeah, that's it. And then we click on the next button and we finish the design of the bridge, and then we proceed with the design of the partial. Yeah, you click on I'm done and you close the CAD software. Once the CAD software has been closed and everything has been saved, we come back to the Dental DB with the same project. We don't need to change anything here. We just continue by clicking on Design Partial. Yeah, and here you will probably notice now that the software loaded again the initial scan, so with the dies, not with the telescopic crowns. So there are two ways, both work fine. You can now continue with this scan and then select your insertion direction here from the inner parts of your second frame, which represents as well the shape of your telescopes. You could also go back into the Dental CAD and save the second jaw scan that we registered with the initial scan. You could save it again as the upper jaw scan, and automatically then the partial software would load this to continue with the design of the partial. Then we click on apply. And you can see that there's no problem for the partial software here with the hole in the scan, and that we are working with the initial scan. Because anyways, even if these parts here are blocked out, this has no influence here on this bridge, which will be merged later with the partial. But this depends on the setting in the add parts step. We could also transform this to wax, but in that case then this block out wax would be removed from the wax, and obviously our bridge wouldn't fit anymore. Okay, yeah, we blocked out the model. Then we can still edit the block out, so I recommend to remove some material here where we place the glass tips. But anyway, you don't need a lot of undercut, as the removable will be taken in mouse by the telescopic crowns by friction. But what I recommend is to add some material here. Let's just switch off the posteriors. And I recommend to add some block out wax here in these regions. Just to make sure that when the partial will be merged with the bridge, that the border here will not be destroyed, and furthermore that your papillas stay clean in this region. Yeah. that's enough. Okay, then proceed to the next step. Now we draw the mesh and the connector. I usually start here in the center. Or it's maybe better to start with the retentions. So therefore I will switch on again my teeth, my posteriors, and then you can do it like I do, because later the finish line will come a little bit deeper. Then the other one. And now I start with the major connector here in the center. You might be asking why I create this shape here. I learned this in the past. This is to think about the future. If once you will lose these tools, it will be much easier to extend the removable if you have this material here in this region. Other people or other users would simply connect it from here to here, but my experience says that this is a good idea to do that and to think about the future. Yes, and then in the edit curve I usually then do some fun tweaking here, and I will try to create a symmetrical design. More material here to connect with the clasps. Yeah, that looks quite good. Then we proceed to the next step. Here we can adjust the retention mesh. I usually go into the settings and I choose a hole size of maximum 3 mm. Then I rotate it and place it like this. And then we can choose different settings. Yeah, we can choose another stipple pattern, and then we apply. Okay. Then we proceed to the next step. Now we can draw the clasps. Usually I do that with a single curve. You can also create clasps with a double curve, so one curve for each side, and even for triple curve, and the third curve might then be the minor connector to connect your clasp with the major connector. But I usually do that with the clone tool, and therefore I just simply use here single curve, proceed to the next step. Then let's apply the clasp, choose the correct profile here, posterior, and in real time you can still change it. Then you apply. Okay, great. Click next or apply. Yeah, then we will work with the clone tool. First of all, with the clone tool, I create the occlusal rests. Like this. Do that freehand. And then I create the minor connector, but I think this one here is, my opinion, it's too thick, and therefore I choose here the connector. And then freehand, I will create here the connection between the clasp and the major connector. Okay, then on the other side, and then let's connect the partial with our secondary frame on the telescopes. I think this is enough. Okay, can even add some material here. Okay. Then let's draw the finish line. Okay, then you can adjust the finish lines here in the next step. Great. Then the other one. Okay. Then we can apply. And we proceed to the next step, which is the add part step. So here we can, in the settings, for example, choose the bridge and change it to editable, so transform it into wax. Then we could merge it already now and smooth and work on it, but then we change the triangulation of it, and also it would be fitted onto the refractory model, and this is what we not want for telescopic crowns. Therefore we don't need to do anything as long as they are dark blue. We can simply proceed here. And now in the last step, in the freeform, we can still freeform here the transitions between the finishing line and the partial. Like this. And then on the other side. We can also hide the refractory. That's an option I really like. And here we can even remove material on the bottom of the partial. This is much easier than grinding it later, and I would maybe recommend to add some material here. Okay. Yeah. Then we can go to the expert mode. We can add retention posts. And we can use all the different options here from the expert mode. I just want to show one more option here is you can load a picture here with the logo of your company, or simply add some text, and then you click on update, and then the text is always horizontal, and then you can place the model in a way that the placement is fine, and then you click on apply. Yeah. Then we go to the last step. The save for build step. Now in this step, this part here will be merged with the partial, and then everything will be exported. This step might take some time, and I've accelerated the process a little bit here, and here's the result. Yeah, let's have a look into the crowns, and you can see here that we kept exactly the shape as it has been created in the CAD application. Thank you for watching.